The request is assigned to a thread from a specific thread pool based on its type. So web container, EJB container, there are different containers in application servers, right? So if it is a servlet or a JSP or any static content, your web container will execute that request. If it is RMI or any EJB calls, EJB request, some complex business logic, right? So that will be executed by the EJB container. So each container will have a thread pool, ORB, Object Request Broker. So this one, yeah, or ORB over RMI invocation, remote method invocations over IIOP protocol. So each one has got a different thread pool. So the thread is assigned to uh, the request is assigned to a thread from a specific thread pool based on the type. And we have seen here the type HTTP, IIOP, SOAP, and there are different other we'll see here. So these threads are pre-allocated in pools to handle requests efficiently. So this is your application and this is a thread pool. All the threads will be queued here, which are in runnable or new or whatever state they are in. So each request comes in and it will acquire the thread from the thread pool and it will run. So it will basically it will execute your task. So at the time while executing, the state of your thread will be runnable. So this is how the thread pool, whatever, like if it is a web container or a EJP container. So the thread pool, this is a process. If the request comes in, acquires the thread, and the task will be running in the task queue, and the response, once it is completed, the response will be sent back. So request and execution process. The thread executes the request by processing the corresponding Java components. So if your if your request is for a servlet or a JSP, Java server page, so based on the request, the thread will be allocated, and from your application, the servlet will be picked based on your context root or subcontext, and that particular code will be executed even if it is a JSP or a EJP. Same, that is the process. In between, it may involve database calls or session retrievals or cache hookups, cache lookups, and business logic execution. So if you have enabled session replication, and if cache lookups are you can configure the cache also. You can use the internal features of WebSphere for dynamic caching. Uh, that is a separate topic actually. So for faster executions, to reuse the data from cache. So you can configure those things, and while execution, your threads may also get involved with database sessions retrieval, if you have enabled the session sticky sessions and cache lookups and any business logic execution. So when this is while executing, and response generation. So once it is executed, after processing, the response is generated and sent back via the same thread. So if the thread involves multiple layers, web container, EJB, database, multiple thread pools interact to complete execution. So here, the first request came to access a servlet. So the servlet is getting executed, and in between it required a database connection. So the same thread will interact with the database connection through connection pool. And again, if it involves an EJB transaction, then the same thread will interact with the EJB container, and the EJB container will have a separate thread pool. So this thread, web container thread, will interact with the EJB thread, right? So
Yes.
that is we have discussed here, they interact with others. Independent execution. Ultimately, the first request that has came to acquire from the thread pool for servlet, right? In between, it may switch to multiple layers, but finally, once it completes the execution, the first thread that is assigned will be back to the thread pool and the response will be sent back. So which threads accept and which threads execute the request? So these threads, web container, EJB, ORD, these are the WebSphere application server thread pools and containers. So usually the threads accepted and execute threads requests. These are different. So these are the thread pools that accept that execute your requests based on the type, but listener threads are different. So thread acceptance is different and execution uh, threads are different. So kernel threads, network listener threads managed by operating system. So the OS maintains socket listeners for incoming TCP or UDP connections. So the TCP stack handles packet processing. The request is forwarded to the application server. So if you are accessing the if using the internal URL, so first your request goes hits the server and the operating system level thread that listens to your request, and usually it will be TCP protocol because TCP is transport channel protocol. So all the HTTP and everything, these are application protocols. These are on top of TCP. So OS maintains these socket listeners for incoming TCP connections. So the request, once this it has its own threads, so it accepts the request and it will forward to the application server. So whatever, if you're accessing directly the internal URL, it will go to WebSphere, or if you have an Apache or Nginx, it goes to that particular process. So web server has its own listener threads. So it creates listener threads that handle HTTP requests. Apache HTTP server uses worker or event threads. So it has got its own mechanism of handling threads. So we call it MPMs. Nginx uses event-driven model with worker processes. So let us not get into this, but usually if the request is hitting the web server has its own listener threads. So the master process listens on the default port numbers, 80 or 443. Worker threads or processes accept the client request, and requests are forwarded to an application server, to the backend server based on whatever you have, Tomcat or JBoss or WebSphere. So in this case, this is a request flow. User is accessing via web server. So web server will have its listener threads. It will listen to the request, and based on the URL, the request header, the content from the request header, it will forward the request to the WebSphere, JBoss or Tomcat, whatever is in the backend. So once it is sent to the backend, this is the process how the request will be handled in WebSphere. So based on the type and thread assignment, how the threads will be assigned from the thread pool, how the request will be processed, and how the response is generated and the response is sent back to the client. So kernel threads, if you are accessing directly the WebSphere application, WebSphere, if you are accessing internal with the internal URL directly, WebSphere application server URL. So if you have a web server, the web servers have their own thread pools. It may have usually we call it worker threads, but Again, it is categorized like different models are used for different web servers. So WebSphere handles different types of requests using specific thread pools. Yes, executing requests, how it executes worker threads. So here is the list. After the request is accepted by WebSphere, it is assigned to the appropriate worker thread. So web container thread pool, EJB thread pool, or which is ORB pool, default thread pool, work manager, and JMS listener. So web container usually it is HTTP based requests. It handles the servlets and JSPs. So these are the web resources from your application. So these threads execute the servlet and JSP logic and return the response. So EJB thread pool, it handles the enterprise Java beans. So EJB is enterprise Java beans, and again, these EJBs are used to uh, develop the complex business logic for banking or e-commerce. There will be lots of complicated business logic that will be developed. So for those kinds of applications, EJBs are created. So EJB thread pool handles the EJB requests, which is business logic. It is used for remote method invocations over IIOP protocol. So this is a method invocation. So remotely, if any client is accessing your EJB, then the thread will be allocated from the EJB thread pool. So usually there is a default thread pool when you start. So these are the default, the first three are the default thread pools. Even if you don't create or don't define, it will start with the default values. And the fifth one also, if you have enabled the JMS module on WebSphere. But work manager, it is something different. So you explicitly create work managers to prioritize the tasks. So default thread pool, it it is used for background tasks, admin tasks, and general purpose processing. For example, batch scripts are running, some data synchronization is happening, and admin tasks usually. So you are deploying an application, or your cluster members are communicating with each other. So these are all the normal background tasks that uh, usually gets executed on your application server. So for these kinds of tasks, default thread pool is used. So work manager used for asynchronous execution, background tasks, and application specific tasks. So why it is given application specific task? Because uh, you may need to prioritize few tasks based on application and uh, critical critical resources. Usually, if you don't create the work manager thread pool, it will use these threads. But if you want to prioritize few tasks and uh, critical business applications require more threads and more resources, then you can create work manager thread pool, and you can define your own thread pool values. And this work manager will also be defined in the application deployment descriptor to utilize to get the resources allocated from the application server. When compared to other applications, any any one or two applications may require prioritization. So at that time, the other applications has to wait for the resources, but these prioritized applications will get the resources. So that is the use of work manager threads. JMS listener processes incoming messages from JMS queue. So these are the types of listener threads actually that work in the application server. So how they execute the request? Yes, thread selection. There will be a dispatcher selects a free thread from the relevant thread pool, web container or ORP or JMS based on what type of request received. So if there is no thread available, then the request queues means it will wait in the queue until any one thread is free. So the thread state idle, the thread is waiting in the pool. Running state, the thread is actively executing a request. Blocked state, the thread is waiting for a resource, for example database connection from the connection pool or network call, or waiting, the thread is waiting for another thread to complete, or timed waiting, the thread is waiting but with a timeout value, session timeout or transaction timeout, and terminated. So these transitions happen in the execute threads. So in the WebSphere application server threads. So here we have seen the normal life cycle of a thread. So it may not be a Java process, but yes, whatever the thread is, like hmm, normal process, the thread life cycle is this one, the generic one. But execute threads, which actually does the work. So this is a, it's almost same, but few more features with few more details. Execution flow, the threads retrieve the session data if applicable, if you have enabled the session replication, and it may process business logic like EJB calls or database calls in between these thread states. While it is executing, it may process business logic, or it may retrieve a session data, or the thread generates a response and returns it. After execution, the thread returns to the pool for reusability. So this is how the requests will be handled, and how what kinds of requests and what type of protocol in different uh, architectures. You may have a web server, you may have a Apache in the front end or Nginx. So based on these web servers, the listener threads will be created, and if you're accessing directly with the internal URL, again the request handling will be different. Right? If it is a load balancer in the front end, it will be different. So ultimately, the Java applications, even if you are accessing with a public URL or internal URL, the core thread pools are web container, EJB or ORB, or JMS. These are the execute threads. Actually, in WebLogic we call it execute threads. These are the worker threads that does actual work, right? So yeah,
Yes.
how WebSphere uses memory for request. So usually whenever you take a thread dump to analyze something, let us say slow responses, users have complained that the application is slow, or they are getting timeout exceptions. So at that time you will take thread dump, but also you will take the heap dump, because both are linked. How it is linked? Heap memory is allocated to store the thread execution data and request related objects, session data, and JVM objects created during request processing. So when your thread is transitioning within different states, it stores its own state, and it stores the application related data in the form of objects, and it also stores the session data. So whenever one request is hit to the server, a session is established with the server when you if you enable the session, the sticky sessions, all the subsequent requests goes to the same server, the sticky sessions. So a session is established with the server, and that session data will be stored. So where all these things are stored in the memory. So for that purpose, heap memory is allocated to each thread. So for each request, one thread will be allocated, and for each thread, some heap memory will be allocated to store all these things. So that is why whenever we take thread dump, we also take heap dump, and we will analyze both